Today's lesson is on unit rate, and we're going to continue on examples of cross multiplication. Let's begin with unit price. The unit price is defined by the price per unit. To determine the unit price, we divide the price by the quantity. What's important to note is that the price, the dollar amount, is always in your numerator. And then you divide that by the amount that is in the unit price. That is called our quantity. What you're looking for is the price per unit, which means how much does it cost for one? There's some examples here. $5 per ticket. This slash here means per. So it's $5 per one ticket. This is a unit price. The price per unit per one ticket is $5. $2.49 per liter is another price per unit or another unit price. So it's $2.49 for 1 liter. And $8.49 per kilogram. $8.45 for 1 kilogram. Keeping all this information in mind, let's practice determining unit prices. A, $6 for 12 oranges. The information given to me says that if I buy 12 oranges, it'll cost me $6. My unit price would be, how much does it cost for 1 orange? So I'm going to take my dollar amount and I'm going to divide it by how many oranges does it cost for that dollar amount. So for $6, that will give me 12 oranges. Remember to have your dollar amount in your numerator. And then I'm going to divide. 6 divided by 12 is 1/2. Because we're dealing with money here, I'm going to convert that into a decimal. So the decimal form of 1/2 is 0.5. And because we're dealing with money, money is always 2 decimal places. So instead of saying 0.5, I'm going to say 0.50. So we understand that this means 50 cents. And now to make this a unit price, we need to have both units that are presented to us in the question in our answer. The 2 units presented to us is dollars and oranges. So they both need to be present in our answer. So we already have the dollars here per orange. I'm just going to write it as a singular form because we're only dealing with, because this only pertains to 1 orange. Let's try B. $1.99 for 18 tea bags. So we're trying to determine the unit price, which means how much does it cost for just 1 tea bag? So I'm going to take my dollar amount and divide it by how many tea bags would that give me? $1.99 divided by 18 is 0.11. I'm going to round it to 2 decimal places because this is a monetary value, and I'm going to include both of my units in my answer. Remember that the dollar sign is placed in front of the monetary amount. When comparing two products of similar quality, the best buy is usually the product with the lowest unit price. Let's determine what the best buy is between these two coffee pod offers. So the first one is $8.99 for 12 coffee pods, or $20.49 for 30 coffee pods. So in order for us to determine what the better buy is, we need to find the unit price for each of them. How much does it cost per coffee pod? Because it's hard for us to determine which is the better buy here when each of these offers don't offer the same amount of coffee pods. So I'm going to start with the first one, taking my dollar amount and dividing it by the quantity. $8.99 divided by 12 is 75 cents per pod. Let's check the next offer. $20.49 divided by 30 coffee pods. And that's 68 cents per pod. So which one is the better buy? Well, let's analyze the amount per coffee pod. So the second offer is cheaper per pod than the first offer. So the better buy here is buying 30 coffee pods for $20.49. Usually the more you buy, the better deal you get. And that's why Costco is so successful in Canada, because they sell in bulk. You usually do pay a little bit more, but you're getting a lot more for that extra bit of money. So that's why a lot of people buy in bulk, because the unit price is lower. It is a better buy. Page 2. A unit price is an example of a unit rate. So a unit rate we can apply to other examples, not just for monetary. How fast you're going or how much you earn are also unit rates. So let's practice calculating unit rates. A unit rate is dividing two quantities that have different units. In the previous page, we were dividing dollars per and then a quantity. So those are two different units. Speed is usually kilometers or miles per either hour or a second or minute. Those are two different units. And earnings is dollar per, usually it's dollars per hour. And those are two different units. So a unit rate is when you divide one unit by another to determine the unit rate. Let's practice determining the unit rate. Sandy rode his bicycle 40 kilometers in 2.5 hours. So when we're determining the unit rate, what we're trying to find out is how far did Sandy ride in 1 hour. We're going to take the number of kilometers and then divide it by time. One thing to note here is that your time is always in your denominator. So it's not going to be 2.5 divided by 40. It's going to be 40 divided by 2.5 because time has to be in the denominator. 40 divided by 2.5 is equal to 16. And then I need to include both of my units in order for this to be a unit rate. My units for this example are kilometers and hours. So I'm going to write my units in the order that I wrote them in my fraction. So I wrote my kilometers in my numerator and then my hours in my denominator. So kilometers per hour. Instead of writing my units in a vertical fraction like they are up here, one on top of the other, they're now beside each other, but in the same order. First my numerator and then my denominator. Sandy rode 16 kilometers in 1 hour. B, the temperature rose 12 degrees Celsius in 5 hours. So my units are degrees Celsius and hours. Since hours is time, remember that time needs to be in the denominator. And this question is asking for the unit rate. So how much did the temperature rise in just 1 hour? So I'm going to take my 12 degrees Celsius, and that's going to be my numerator, and divide it by 5 hours. 12 divided by 5 is 2.4. And then my numerator units per denominator units. So in 1 hour, the temperature rose 2.4 degrees Celsius. Jasmine is remodeling her living room. She's looking at 2 options for floor coverings. Option 1 is 20 meters square of floor tiles that costs $1,050. Option 2 is 96 square meters of carpet for $4,449.50. So immediately looking at the 2 quotes, you're looking at the prices and you're saying, well, option 2 is way more expensive than option 1 because the question is determine the most economical choice. And economical means the best buy, the more affordable choice. So we shouldn't just keep into consideration the price. We also should look at the amount of flooring that is going to be covered. So here in option 1, only 20 square meters of floor is going to be covered for $1,050. In option 2, we have almost 5 times the amount of flooring that will be covered for about 4 times the amount of money. So this is why we need to find the unit rate in order to determine what the better buy is. Because by looking at these quotes, it's hard for us to determine which one is the better buy. Let's determine the unit price for option 1. Now remember, your dollar amount goes in the numerator. $1,050 divided by 20 square meters of tiles. So that's equal to $52.50 per square meter of flooring. It's going to cost $52.50 for every square meter of flooring. Let's look at option 2. $4,449.50 divided by 96 square meters. That's equal to $46.35 per square meter. So this means that it's going to cost $46.35 for every meters squared of fluorine. So let's answer the question. What is the most economical choice? Well, looking at the unit rates, it's a better buy to go with option 2. Even though you're spending 4 times the amount, you'll cover a lot more area of fluorine than if you went with option 1. So now that we are experts at unit rates, let's compare what the difference between a ratio and a rate is. A ratio is a comparison of quantities that measure with the same units. Example, apples to apples. 1 green apple versus 2 red apples. They're all apples. It's all the same units. Whereas a rate, which we just did above, is a comparison of quantities measured in different units. For example, centimeters and meters are not the same units. Dollars per hour is not the same units. A proportion is a statement showing that 2 ratios in rates are equivalent, which we've also learned, and we're going to continue to practice below. And that's when we have to cross multiply. When you have 2 fractions or ratios, however they are presented to you, and they're equal to each other, that means that they should be equivalent to each other. There is a scale factor that is shared between the 2 ratios. Let's identify the rates and ratios on this list. So it says to circle the rates. So again, rates mean that they have different units. So 1 gigabyte to 10 minutes. Those are different units. So that's a rate. 3 centimeters to 6 centimeters. That's the same units. So that's a ratio. So I'm going to go ahead and underline to represent a ratio. $125 meters to 100 meters. The same units, so that's a ratio. $20 to 5 tickets. Different units, so that's a rate. 50 milliliters to 100 milliliters. Those are the same units, so we're going to underline that to represent a ratio. 0.5 kilometers to 5 seconds. Different units, so that's a rate. 100 kilometers to 1 hour. Different units, that's a rate. 350 meters to 5 seconds. Different units, that's a rate. We learned last lesson about solving proportions with cross multiplications. We're just going to do a few more examples just to consolidate our learning. Now remember that we can only cross multiply when there is an equal sign that separates our 2 ratios. So let's cross multiply to solve for our variables. So remember, our numerator is going to be multiplied by our opposite denominator, and our numerator is going to be multiplied by our opposite denominator. So x times 9 is 9x, and 18 times 3 we will write as multiplication on the right side. The whole point of cross multiplying is to get rid of fractions, and it's easier to find x when we're not dealing with fractions. 9x is equal to 18 times 3 is equal to 54. X is equal to 54 divided by 9. X is equal to 6. B, 3x is equal to 7 times 5. 3x is equal to 35. X is equal to 35 divided by 3. Now, since this is not going to give me a whole number, I'm going to leave it in fraction form. I can't reduce it, so we're finished with this one. X is equal to 35 over 3. Next, 5 times 9 is equal to 5x. 5 times 9 is 45 is equal to 5x. 45 divided by 5 is equal to x. 9 is equal to x. Last question. 4 times 10 is equal to 2x. 40 is equal to 2x. 40 divided by 2 is equal to x. 20 is equal to x. There are some homework questions for you to complete at the bottom. If you have any questions with today's lesson, please join today's Zoom, or you may message me or email me. Great job.